Hey guys, in case you missed our lesson today or you need a refresher, this video is going to be on what we covered in class, linear functions. So before we get into the grit of it, try and recall what it means to be a function. You can pause and write down your thoughts. A function is a relationship where each input x has only one output, that is y. So since we're talking about linear functions, take a second to think, what does a linear mean? Linear refers to something being in a straight line. Here are some examples of graphs of linear functions. As you can see, they are both straight lines and can have a positive or a negative slope. Here are some examples of nonlinear functions. As you can see, they are not straight lines, but they are functions by our definition. Now here's the tricky part. It can be a straight line, but it also has to be a function to be a linear function. So a horizontal line is a function by our definition, but a vertical line is not. So let's imagine that a new store called Dollar Mart has just opened up on the corner. Let's go check it out. Once inside, we find out that each item only costs $1. So to get a better idea of how much we can buy, we're going to try to graph the relationship of cost per item. So we will start by creating a table where x is our number of items purchased and y is our total cost in dollars. So for one item, we pay $1. For two, we pay $2, and so on. Then we graph those points from our table on the plane. When we draw a line through all of those points, we get a linear function. In fact, this linear function is the equation y equals x. Its rate of change is 1, and we calculate this by looking at 2 points, in this case 2, 2, and 3, 3, and calculating it based on our formula. Recall that the rate of change is denoted by m. So a more general equation for our previous is y equals mx. How would our equation and graph change if instead of $1, each item now costs $2? So we created a new table where the cost is now $2 per item. Then we plot those points on the plane. We then connect the points that we have plotted with a straight line. This equation is y equals 2x, where 2 is the slope denoted by m. Here's my question to you. Is y equals 2x still a linear function? Pause the video and write down why or why not. Without making a table or graphing like we did before, would the function be linear if it were $500 per item? Pause and record your answer. The answer to the two previous questions is yes. The reason is that both have a constant rate of change denoted by m. Now, we just heard the news that Dollar Mart has required we buy a membership in order to shop in their store. The one-time membership fee is $55. The cost is still $1 per item, so our rate of change is still 1. However, if we don't buy any items, we are still paying $55. We represent this as y equals 1x plus the 55. This is a derivation from our point slope form y equals mx plus b. Y equals mx plus b is our slope-intercept form because b is where the function intercepts the y-axis. A suspiciously identical-looking competitor store has also opened and is now charging membership at only $25. This competitor, called Double Dollar, has a one-time $25 membership fee. However, the cost is $2 per item, so our rate of change is 2. And when we don't buy any items, we are still paying $25 for the membership fee. We represent this with the equation y equals 2x plus 25, where 2 is our rate of change and 25 is the membership fee.
created using Powtoon.